Hi, everybody. So I'm out today and I want to go over these notes that I have left for the sub. But before we go over these notes today, I thought it might be good if we discuss some of the homework that you had technically due today. So while it's kind of fresh in your mind, I figured I'd go over some of those problems. Let me switch my camera here. All right, so in particular, every year I know kids have problems with number 2 on the homework. And so I just thought we'd talk through that here before I go on to the notes for today. So on number 2, it says a density curve. We know a density curve has area of 1 underneath it. So the area under this curve is 1. It also describes the curve as going through the point 0, 0 and having a slope of 1/2. So this is a very mathy problem. So, if you don't love math, and this is going to be a very frustrating problem for you. But let's just write down some information. So I drew a picture. The curve goes off at a slope of 1/2. So I could write the equation of this line, y equals 1/2 x. And I know the area underneath it has to be 1. And so I know that this picture sort of looks like this, because if I go out to 2, I know that the area of that triangle will be 1. So I know that this has to be the density curve. I have to go out to 2. If you just think about it, if x is 2, then y is 1. And so I've got a right triangle. And so the area of that triangle is 1, like I need the area under the density curve to be. Okay. So if I determine the median, the first quartile, Q1, and the third quartile. So if we do a little math, the equation here, instead of saying, if we stop at a certain point, then the area to the left is sort of going to help us determine where the quartile is. So in other words, I would need to stop somewhere where 1/4 of this area is here. Once I find that spot, that's Q1. Wherever I stop, where I have half the area here and half the area here, that's the median. And then wherever I stop so that 3/4 of the area is down there, that would be Q3. And so that's our goal. And so if we look at the area formula for this, based on our x value, so whatever x value we have, we are going to have a right triangle. And so the formula for that is pretty simple. It's 1/2 base times height, the base being the x value, the height being what the y is when I put the x in. So I can substitute out, the height is just my y, and that's 1/2 x from our formula. And then the x is just the x value, and then 1/2. So I can simplify the area formula. 1 is equal to 1/4 of x squared. That's for the whole thing. And you can see if I put a 2 in here, that's 4, and 1/4 of 4 is 1, just to kind of show that. But that formula, the area formula, we know it's 1, but it won't always be 1 depending on where we stop for x. So we know for the median, I know that I want the area to be 1/2. So I'm just using this formula here. 1/2 is equal to 1/4 x squared, and solve that for x squared. That becomes the square root of 2, which is something like 1.41. So, 1.41. So the median would be about right here. Okay. And then for Q1, I want the area to the left to be 1/4. So I use this formula again, 1/4 equals 1/4 x squared, solve that, x is 1. So if I drew a line right here, this area is 1/4, 3/4 of it is over here. Same thing for Q3, I set the area to the left to be 3/4. 3/4 is equal to 1/4 x squared, solve that for x, and I get the cube root of square root of 3, okay, which would be somewhere, around here or so. All right, relative to the median, where would the mean be located? So this is kind of skewed to the left. And so as a result, the mean will be pulled down into the left, and it will be the left of the mean. the median, sorry, the mean will be to the left of the median, okay? And then what percent of observations lie below 0.5? So if I look at 0.5 here, I basically just want to find that shaded area. And so I go back to my area formula, putting in X of 0.5 in, we get about 6%, 6.25%. And then above 1.5, so 1.5 is here. And you know, I could still use this formula to find the area to the left, and that's this. So that's percent. And so we would want to just subtract that from 100, and we get the other one, 43.75% of the observations are to the left of that, okay? The only other question that people sometimes have is on number 4. Number 4 is, you know, it's not one right answer for this. It just depends on your analysis. So what I did for this, my answer is, you know, the cup is 8 ounces. So if it's equal to 8 ounces or it's more than 8 ounces, you're going to spill. And I don't want any spillage because I don't want anyone to get burned. So my thought is, I don't really want it very often to even go over 7 ounces because you know, if you leave a gap at the top, then, you know, someone's not going to get burned. So that's good. And so that's what I've done. And if you think about the empirical rule, I set my 3 standard deviations above the mean to be 7. And so, you know, as a result, they told us what the standard deviation of 0.2 is. Probably not realistic that we would know that, but they told us that. And so then I can just go down 0.2, 0.2, 0.2, and that gives me a mean in the middle of my normal distribution of 6.4 ounces. So that's what I would set my median. Yeah, there's going to be some times where, you know, often people feel like they get gypped a little bit, like maybe there's not enough coffee in the cup. But my main concern in answering this question is to make sure that no one gets burned. Okay. So those were the main questions that people have difficulties with. Let's talk about today's notes then. And we're going to talk about assessing normality. So I'm looking at these notes here. Your sub should have given those to you today. And so I'm going to suggest that you take your data. This is cubic feet capacity of refrigerators. So a sample of 36 side-by-side refrigerators and what their cubic feet capacity was of the refrigerator. And so we have this set of data and we want to know, is this data normal? And so what we could do is put those into your calculator into list 1. And so I made it a little bit nice because I went ahead and put them in order for you so it would make it a little bit easier. But you might just pause this video and put this data into list 1. I'm going to go ahead and talk through it though. And then we go to plot 1, we turn it on and we turn it into, we select histogram, and then we do, we graph, and you might get an error of some sort. Make sure that all your Y, your plot, your graphing is off. Zoom 9 often clears out your errors, so try that. But you should get a graph like this. Now, the calculator picks the class widths, which might be kind of nonsensical, but you can see this isn't, you know, so you can't really tell, right? I mean, it doesn't look horribly unnormal. If we picked better class widths than the calculator does, maybe we would get something that looks a little bit normal. But another way we could do it is look at finding the mean and the standard deviation. So if you go and do a 1-var stat from this data, once you put it in here, go do a 1-var stat, and it will give you your X bar and your S. And so if you put that data in correctly, I think you should get 15.825 is the mean of all of these. And the standard deviation of 1.217, okay? So your calculator will give that to you when you do your 1-var stat. So what I thought we could do is, let's see if we use this mean and standard deviation to do some calculations of some intervals using our empirical rule. So let's see if this data falls into the empirical rule percentages that we know from our last lesson. Remember, the empirical rule is about 68, 95, and then like 99.7, right, are the empirical rules. So let's see if we do a mean plus or minus one standard deviation. So we take this and we subtract this, and we take this mean and we add this, and we get the following values. So we would get something like 14.608. So like an interval, low and high end, we would get 17.042. So again, I took the mean and subtracted the standard deviation and added the standard deviation, got two numbers. Now what we could do is go back and count how many of these data, and this is a little bit easier because I put them in order, how many of these data values fall in this range. And if you go back up and you count how many there are, you'd see that there are 24. Okay. And then if we think about 24 out of the 36 total that are up there, that is about 0.67, pretty close to the 68% for the empirical rule. Okay. And now let's do the same thing. Let's do the mean minus 2 of these and the mean plus 2 of these. And what would we get? 13.391 up to now 18.256. So if we go through our data set and figure out how many of these data values fall between these two things, of course, we're going to get more, right? Because now we're out further, and so we're going to get more. And so that ends up being about 34 of them. 34 of 36 ends up being about 0.94. And then finally, do the same thing, the mean minus 3 and the mean plus 3. So we're going to do 1 standard deviation, 2 standard deviations, 3 standard deviations. All right, and so then those numbers are 12.14174 up to 19.476. Now, how many of those data values fall in that range? And all of them do, 36. So if we go plus or minus 3 standard deviations, we've encompassed all of the data. And so as a result, that's 100%. So remember, the empirical rule is what? 68%, 95%, 99.7%, right? So these fall pretty close to that. So just another way of like looking at it. But you can see this is pretty tedious. Like I wouldn't want to have to go and count for every data set how many of these things fall into plus or minus 1, plus or minus 2, or plus or minus 3 standard deviations from the mean. That's really tedious. So even looking at this and trying to figure out from the histogram whether it's normal is also a little tedious. We have a more efficient way of doing it. Okay. So if we go now, we have our data. Hopefully you've actually put your data in. So, if you didn't pause, you should have put that data in your calculator and then start the video again. But we have a way, and it's called a normal probability plot. And it's one of our plots in our calculator. So if you go back to turn on to plot 1, turn it on, and instead of a histogram this time, go to the very last one. It just looks like almost like a linear graph with dots in it. But this is a normal probability plot. Once you select that, it's going to ask you for your list. Leave everything else the same. But list 1 is, assuming your data is in list 1, and then you ask it to graph it. Now you will probably need to do a zoom 9 to get it to fit properly. And what this is doing is it's sort of complicated, but it's dealing with the z-score for each data value, comparing it to like sort of the mean, right? The mean value. But ultimately, all you need to really know is that if the normal probability plot is fairly linear, then that means our data set is normally distributed, okay? So that's all we really have to do. So if the points in the normal probability plot lie close to a line, then the data is approximately normally distributed, okay? And then I have here a sheet of other examples. So like this data is clearly fairly normal, but what I did is I took my graphing calculator and I plotted some others that maybe weren't so normal. So like this one, this is a histogram clearly skewed to the right. Notice sort of linear up here, but then it curves down and it's sort of bunched up a little bit, right, on the end. So that is what we would expect to see when it's skewed to the right. This one, not exactly normal, but sort of symmetrical. You can see it's kind of linear, not awful. This is not clearly a perfectly normally distributed, but it's not skewed one way or the other. It's fairly symmetrical. So again, we got a pretty linear relationship in these dots. And then the last one here is skewed left. So it's, linear again down here, but this time curved and sort of bunched up on the right. So that's kind of what you would expect when skewed left or skewed right. And then, of course, you could make up data and put this into your Google, into your calculator yourself to sort of test this. But I sort of did it for you so you can kind of see what it looks like when it's not normal. Okay. All right. So there's not really any homework tonight. Next class, we will continue our discussion of z-scores and resulting probabilities. So, but actually no homework tonight. All right. We'll see you next class.